Hello everybody and welcome to another math tutorial video. I hope you're all having a great day, and in this one we're going to be looking at multiplying radical expressions, which is on IXL L7, and our directions are to multiply and write in simplest form. Now I'm not going to rewrite those directions every time. That's basically what we're doing on all of these. So let's get right to it. This one is a little bit tougher. So we have the square root of 6. Anytime I have the square root or the cube root or the fourth root, whatnot, if it's written like that, that would be a radical. So we have the square root of 6 times the square root of 234. So already we can tell this is going to be a little bit crazy. So basically how to do this is we're going to do the square root of, well, 6 and 234 both are not perfect squares. So what I'm going to do is I'm going to multiply 6 times 234. I'm just going to group them because they're both the square root of them. Kind of like what we did when we grouped on M2. If I had a different base but the same exponent. Basically here the exponent is 1/2. So both of these are to the 1/2 power. So when I do this, I'm going to get the square root, and then you're going to see what that is. And when I multiply those, I end up getting 1,404. And whoa, my 4s really don't want to write. Okay, so we have 1,404. And I'm like, whoa, that's a big number. Well, one thing that I can do on this is I can consider what my perfect squares are. And let's see if I can break this down. So my perfect squares. You also can use prime factorization if you really like that method. You can do that, but you don't have to do it that way. So I know that 1 is a perfect square. Of course, 1 ain't going to do anything, but I'll write it anyway. And then 2 to the second power is 4, so 4 is a perfect square. 3 to the second power is 9. 4 to the second power is 16. 5 to the second power is 25. 6 to the second power is 36. And, 49. I'm just going to keep going. And 8 squared is 64. 9 squared is 81. 10 squared is 100. Now, of course, we could keep going. 11 squared, 12 squared, so on. But I think probably one of those perfect squares here will break this down. So if you weren't sure, use your calculator. Let's try, I know 1404 is an even number, so let's just try dividing it by 16 or 36. Let's try one of those, or 64 maybe. And if it doesn't work, we'll try the other ones. But, you can use your divisibility rules. I know it ends in a 4, so it would be divisible by 4 for sure, but that's probably not going to be the biggest one. If I try 36, oh, it does work. So, in this particular example, I know 36 works. So I'm going to circle that. And so when I break that down, it's going to be the square root of 36 times 39. So 36 times 39. No, wrong thing. And since 36 is a perfect square, I'm going to circle it because that tells me it's going to come out. So now, there may be a case where, for example, if 39 also had a perfect square in it, I'd have to break that down more. But 39 does not have a perfect square in it, so I don't have to worry about that. So the square root of 36 is 6, so I'm going to have 6 on the square root of 39. 39 has to stay inside there because it does not have a perfect square inside it. Okay, so let's look at another one. was a little bit crazy, wasn't it? Just a little bit. So on this one, let's say that we have, let's throw a variable in here. Let's say that we have the square root of 14 v to the 5th times the square root of 15 v to the 2nd. Alright, on this one, okay, so we're going to do it just like we did on the last one. Same rules are going to apply. So we're going to do the square root of 14 v to the 5th times 15 v to the 2nd. Okay, so 14 times 15. See what that is. So that gives me 210. So we're going to have the square root of 210. Now, if you go back to when we did M2, when we multiplied rational exponents, I know that if I'm multiplying the same base, my base is v, so I would add my exponents. So 5 plus 2 is going to be 7, so I'm going to have v to the 7th. We're basically just using those properties of exponent rules. Alright, so here's where things get a little bit complicated. Okay, if I try to divide 210 by any perfect square that I know, it won't divide by 4. If it won't divide by 4, think of your divisibility rules. My last two digits are 10. 10 will not divide evenly by 4, so 210 will not divide by 4. So if it won't divide by 4, it will also not divide by 16, 36, so on. If I tried 49, 49 is another perfect square. I don't think it divides by that either. No. So pretty much this one is not going to be able to do much. I can't divide it by 9 either, because remember, to be divisible by 9, all of the digits have to add up to a multiple of 9. So 2 plus 1 plus 0 is only 3. 3 will not divide by 9 evenly. So really, this is simple as it can get number-wise. However, the v to the 7th will simplify. So if I have the square root, I'm going to go ahead and leave the square root of 200. Hold on. I'm trying to figure out how I want to do this. I'm going to go ahead and leave the square root of 210 in there, but we're going to end up having to take out the v to the 7th. So basically, I'm going to simplify this. So I have the square root of v to the 7th. Square root means I'm doing the 1/2 power. So I'm going to do 7 times a half, or 7 divided by 2. So when I do that, I'm going to put 7 inside and 2 outside. Okay, and let's see what that ends up being. 2 goes into 7 3 whole times. 3 times 2 is 6. So when I subtract, I get 1. So I'm going to have 3 remainder 1. So what does that mean? Well, what that means is in my answer, I'm going to have 3 v's that came out. I'm going to have v to the 3rd outside. So in my answer, I'm going to have v to the 3rd, and then I still have my square root. And that 210, that thing's stuck in there, so it's just going to stay right in there. But I had 1 v, I had a remainder of 1. So that means 1 is stuck inside there. So I have v cubed times the square root of 210 v. And that would be really all I could do on that one. Okay, so let's look at another one. Yeah, I think that's really all. Yeah, that's all we can do on that one. Okay. So, not really as bad as it looks, is it? Maybe, just a little bit. Alright. I think we can do it. So, we have on this one the square root of, whoa, this thing is square root of 98q. Q is another one I have to be careful about, because if I'm not careful, my q's look like 9s. So I have the square root of 98q to the 3rd times 3q to the second, the square root of 3q to the second. Okay, so we're going to do the same thing here. So we're going to do the square root of 98q to the third times 3q to the second. Okay, so 98 times 3, what's that going to be? That is 294. So we're going to have the square root of 294. Crap. Yeah, there we go. And then, of course, my base is q. So I'm multiplying, so I'm going to add my exponents. So I'm going to have q to the 5th power. Okay? So 294, that might have a perfect square inside of it. 94, that's not going to divide by 4, I don't think. But let's just try some things. Let's see, 294, let's divide that by 49, just see what happens. Oh, that works. Man, I'm a lucky guesser, I guess. Okay, just a little bit too crazy, I guess. So that's going to be square root of 49 times 6, because 49 times 6 gives me 294. And then, of course, I still have my q to the 5th. Okay, so this 49 is a perfect square. So I'm going to circle it because I know it's going to come out. So that means we're going to have 7 because the square root of 49 is 7. And then I'm going to have inside still 6. 6 has to stay in there. 6q to the 5th. Now the only last thing here is to deal with our q's. So we have q to the 5th. So basically I'm going to do 5 divided by 2. Just like we did in the last one. So I know that 2 goes into 5 2 whole times. 2 times 2 is 4. So when I do that, I'm going to have 2, remainder 1. So what that means is, for my final answer, we're going to have 7. This is being very uncooperative. We're going to have 7. Okay. And then 2 q's came out, basically q to the second. So we're going to have q to the second. Man, this is really not cooperating. 7q to the second. And then I still am going to have some stuff inside that radical. So I'm still going to have 6 inside, and I'm going to have, since I had a remainder of 1, I'm going to have 6q to the first. So I'll just leave that as 6q. And that's really it. Okay, let's try one more. So on this one, let's do a hard one. So let's do square root of 35 m to the third n, and all that's under the square root, times square root of 5m to the fourth. Okay, so this one looks hard, but it's really the same thing. So I'm going to do the square root of, and I really don't need to show this step again, do I? 35 times 5, let's see what that is. I think 175. Yep, it is. So I'm going to have 175, and then I'm going to add my exponents. So I'm going to have m, 3 plus 4 is 7. So m to the 7th. But the only n I had was just that one. So that's going to stay like that. So, okay, that 175, I know that has to have something inside it. So a perfect square. A perfect square that's inside 175 would be 25. So I'm going to have the square root of 25 times 7. Okay, and then I'm going to have m to the 7th n. Okay, so 25 is a perfect square, so we're going to circle it. So we're going to have 5, because square root of 25 is 5. And then I'm still going to have inside the 7 m to the 7th. Whoa. So 7m to the 7th n. Now, we're not done, because I have m to the 7th inside there, and I know some of that's going to come out. Regarding the n's, I only have 1 n in there. In order to come out, I need to have at least 2 n's, because we're doing to the 1/2 power. We're doing square root. So to have a perfect square, I'd have to have n to the 2nd. But I have m to the 7th, so let's deal with that. So we're going to have to deal with this. So we're going to do 7 divided by 2. One thing to note, if I had the cube root, I would do, instead of dividing by 2, I'd divide by 3. Or the 4th root, I would divide by 4, and so on. So 7 divided by 2, that is going to be 3. So 3 times 2 is 6. Subtract. So I'm going to get 3, remainder 1. So my final answer is going to be 5. I still have that 5 out there, can't forget it. So I'm going to have 5, and then m, how many came out? 3 came out. So I'm going to have 5m to the 3rd. And then inside that, whoa, what are we doing now? I don't know how I switched to that. Oops. I'm going to try to fix this. Whoa, it's not what I wanted to do at all. So, hold on. Crap. No, I don't want that. Sorry about that, y'all. Well, we almost made it, and then delete. Delete. Not let me delete that. Well, that really is unfortunate. I don't know how I got it on that, but I can't erase this either. Can I just move it? Yeah, I could just move it out of the way. Let's just do that. Oh my goodness. Technology is wonderful, but when it messes up, it's like, well, all right. So we have 5m to the 3rd, and then the square root of 7 has to stay in. But how many m's did I have? I had 1 that's still stuck in there, so be careful, don't forget it. And of course I had an n that had to stay in there as well. And that is really all for that one. Alright, so that's all for this video. If you have any questions, feel free to message me. Hope you have a wonderful day, and as always, stay awesome. Good.